Okay, I hear the recording in progress. So share the screen. Okay, on paper, it's supposed to be up to 4.6, but I'm already on the 4.7. So I think we're a little bit ahead and we'll be okay. So continue on with 4.7 today and tomorrow. So maybe the new schedule is 4.7, 2 days, 4.8, 2 days. Then we still have all of next week to do 4.9. And my video just froze. So I'm gonna have to stop and start again. See if I can get back in. Something's not right. So okay. I'll try something else. So let me unplug this and try to plug it back in. We're good now. Okay. All right, so continuing on with 4.7 today. So major formulas are the Pythagorean identities, page 239. Sine squared x plus cosine squared x equals 1. Again, the normal way to write it is the 2 is up here, sine squared, cosine squared. 1 plus tangent squared x is secant squared x. 1 plus cotangent squared x is cosecant squared x. Okay. And I gave you the formulas for the sine of a sum and difference, likewise cosine of a sum and difference. Okay, so we'll be using those. Double angle formulas, sine of 2x, 2 sine x cosine x. Cosine of 2x is cosine squared minus sine squared. There's also 2 cosine squared x minus 1, and 1 minus 2 sine squared x. You're welcome to put all of these in your formula sheet. Okay. Half angle formulas on page 246. The varieties we're going to be using mostly are these two because these are the ones that you'll have in calculus the most. So sine squared x, 1 minus cosine 2x over 2, cosine squared x, 1 plus cosine 2x over 2. You may put these on your cheat sheet. Heads up that your calculus teacher might make you memorize these, okay, especially if we're back to being face-to-face by next semester or the semester after that. We'll see. But and the last time I taught, I made my class memorize this also. Things frozen on me again. It's going to be a regular pattern. Okay, so a series of starts and stops. Get my sheet here. Try it again. All right, looks like we're back in business until the next time it messes up. All right, number 5. Tangent of pi over 12. Now, pi over 12 is 3 pi over 12 minus 2 pi over 12. They don't give us a formula for the tangent of a sum or difference. It actually exists, but let's assume we don't have it. Well, tangent is sine over cosine. Sine of 3 pi over 12 minus 2 pi over 12 over cosine 3 pi over 12 minus 2 pi over 12. 3 pi over 12 is pi over 4. 2 pi over 12 is pi over 6. Cosine pi over 4, pi over 6. So first I drew myself a 45-degree angle, pi over 4. Both x and y are radical 2 over 2. Then pi over 6 is 30 degrees. Again, those angles that have a reference angle of 30 degrees, either x or y is a half. So it looks like y is a half, therefore x is radical 3 over 2. All right, so sine of pi over 4 minus pi over 6 by formula, sine of the first, cosine of the second, minus cosine of the first, sine of the second. So sine of pi over 4, y coordinate, radical 2 over 2, cosine pi over 6, x coordinate, radical 3 over 2, minus cosine 45 degrees, radical 2 over 2, sine of 30 degrees, 1/2. Common denominator is 4, so radical 6 minus radical 2 over 4. Denominator, cosine pi over 4 minus pi over 6, cosine of the first, cosine of the second, plus sine of the first, sine of the second. Okay. Both cosine and sine of pi over 4 are radical 2 over 2, this one and this one. Cosine pi over 6, x coordinate, radical 3 over 2. Sine of pi over 6, y coordinate is 1/2. So radical 6 plus radical 2 over 4. Therefore, tangent of pi over 12 is sine of, where'd it go? Pi over 12, that came out to be radical 6 minus radical 2 over 4, divided by cosine pi over 12, that came out to be radical 6 plus radical 2 over 4. The 4's drop out. Final answer, radical 6 minus radical 2 over radical 6 plus radical 2. You may leave your answer like that. Just stop there. Okay, number 7, sine of 7 pi over 12. First thing I notice is that's in the second quadrant. So how do you know that? Well, 6 pi over 12 is pi over 2. That's 90 degrees. So I go a little bit more. I'm in quadrant 2. Quadrant 2, the sine of the sine, S-I-G-N of the S-I-N-E is positive. So I will have to keep that in mind. Then I'll use the identity sine squared of theta is 1 minus cosine 2 theta over 2. So for the directions, number 7, you want us to use either a double or half angle formula to work out something like number 7. So I don't recognize this, but I do recognize twice that angle, which is 7 pi over 6. So if I multiply this by 2, 7 pi over 6, I can figure that out. So I use the identity sine squared of theta is 1 minus cosine 2 theta over 2. So sine squared of 7 pi over 12 is 1 minus cosine 7 pi over 6 over 2. That's sine squared. So sine is the square root of that. I'm in quadrant 2, so I want the positive S-I-G-N. So 1 minus cosine 7 pi over 6 over 2. So I go to 7 pi over 6. Pi is 6 pi over 6, and I go another 30 degrees. Okay, I want the x coordinate. Well, y is halfway down, so it looks like it's going to be negative radical 3 over 2. So I have the square root of 1 minus parentheses negative radical 3 over 2. So 1 plus radical 3 over 2 divided by 2. You can simplify it a little by multiplying top and bottom by 2. So I multiply top and bottom by 2, that cancels that out. And this becomes the square root of 4, which is just regular 2. And underneath the radical, I have 2 plus radical 3. So that's my final answer. Square root of 2 plus square root of 3 all over 2. Yeah, I know it looks funny, but that's the way it works. It's a square root inside a square root. Okay, number 9. Cosine of 5 pi over 8. Okay, 5 pi over 8. I'm in quadrant 2, so I know the answer is negative. Okay, how do I know it's a quadrant 2? Well, I know 4 pi over 8 is pi over 2. So 5 pi over 8 is a little bit more. That lands me in quadrant 2. So the sine, S-I-G-N, of cosine 5 pi over 8 is negative. Okay. And again, the game that I'm playing is I don't recognize 5 pi over 8, but I do recognize twice that angle. If I double that angle, multiply by 2, that becomes 5 pi over 4. 2 times 5 pi over 8, cancel the 2 with the 8, 5 pi over 4. And I do recognize 5 pi over 4. That has a reference angle of 45 degrees. So I use the identity cosine squared theta is 1 plus cosine 2 theta over 2. So cosine squared of 5 pi over 8 is 1 plus cosine 5 pi over 4 divided by 2. Take the square root of both sides, and I want the negative S-I-G-N because I'm in quadrant 2. So negative square root of cosine of 5 pi over 4 is negative radical 2 over 2. So square root of 1 minus radical 2 over 2 all over 2. There's a lot of 2's here. And then again, to simplify it, multiply top and bottom by 2 here. There's a negative in front of the whole thing. So 2 times 2 is 4. Square root of 4 is just regular 2. Underneath the radical is 2 minus radical 2. So final answer is negative square root of 2 minus square root of 2 all over 2. A lot of 2's and some funny square roots, but this is the final answer for that one. Okay. All right, then how do I do something like 13 and 15? Use the given information to find each value. Cosine 2t, sine of 2t, cosine t over 2, sine blah, blah, blah. Okay. So cosine of t is 4/5. T is between 0 and pi over 2. I'm in the first quadrant. That's nice. So first I need the sine of t. Cosine squared t plus sine squared t is 1. Sine squared t plus cosine t is 4/5 squared. 4/5 squared is 16 over 25. Subtract 1 minus 16 over 25, 9 over 25 is sine squared t. Take the square root. Sine of t is 3/5. I am in quadrant 1. So cosine t is 4/5. Sine of t is 3/5. All right, now they ask for cosine of 2t. So the identity is cosine squared t minus sine squared of t. So cosine t was 4/5 squared minus sine squared of t 3/5 squared. 16 over 25 minus 9 over 25, 7 over 25. Then B, sine of 2t. By formula, 2 sine t cosine t. So 2 times sine of t was 3/5. Cosine of t was 4/5. Multiplying together, 24 over 25. All right, they ask for cosine of t over 2. Okay, one thing to check. The angle is in quadrant 1. So half that angle is still going to be quadrant 1. Okay, so I want the positive value. Well, cosine squared of theta is 1 plus cosine 2 theta over 2. In other words, to go from here to here, I double the angle. So go from here to here, I double the angle. What's double t over 2? T. So cosine squared of t over 2 is 1 plus cosine t over 2. Then I just take the square root to figure out cosine of t over 2. So square root both sides. So the square root of cosine squared t over 2. So 1 plus cosine t came out to be 4/5. Okay. So cosine squared of t over 2 is 1 plus 4/5 divided by 2. That's 9/5 divided by 2. That 5 can slide down with a 2, so I have 9/10. Take the square root of both sides, and I have the square root of 9/10. Square root of 9 is 3. So 3 over radical 10. I don't mind that you leave it at 3 over radical 10. If you want to rationalize the denominator, 3 radical 10 over 10, that's also fine. Both of those are good as far as I'm concerned. Then it asks for the sine of t over 2. Again, I'm in quadrant 1. If t is in quadrant 1, half of that's still in quadrant 1, so I want the positive. So identity, sine squared of theta is 1 minus cosine 2 theta over 2. So to use the formula to go from here to here, you double the angle. So sine squared of t over 2, double the angle, you have t, 1 minus cosine t over 2. So sine squared of t over 2, 1 minus cosine of t was 4/5. 1 minus 4/5 divided by 2. So 1/5 divided by 2 is 1/10. Take the square root of both sides. Sine of t over 2 is the square root of 1/10, or 1 over radical 10. Again, I don't mind that you leave it that way. That's fine. Okay. 17. Verify the identity. Show that sine of blah, blah, blah is equal to negative cosine t. You basically just do it. So sine of a sum, sine of t plus 3 pi over 2. So by formula, it's the sine of the first, cosine of the second, plus the cosine of the first, sine of the second. 3 pi over 2, that's down here, south pole. The ordered pair is 0, -1. So cosine 3 pi over 2, x coordinate 0. Sine of t times 0, that's gone. Cosine of t times the y coordinate right here is -1. So the final answer is negative cosine t. Okay. So that's 17. You can do 19 and 21 in a similar fashion. Now, how do you do something like 23, 25? Use a half angle formula to rewrite the given expression so that involves the sum or difference of only constants and sine and cosine function to the first power. That means don't have your answer with a square or fourth power or whatever. How do you do that? So this is what you do. So 25, sine to the fourth x. That's sine squared squared. Okay, sine squared is 1 minus cosine 2x over 2. Okay, and that comes out to be, bottom is 4, 1 minus 2 cosine 2x plus cosine squared 2x over 4. Okay, so we almost got it, but they don't want any squares in my answer. So I rewrite this as 1 over 4 minus 2 divided by 4 is 1/2 minus 1/2 cosine 2x plus 1/4 cosine squared of 2x. So in the directions, they don't want any squares. So I have to change cosine squared of 2x. So leave that alone, leave that alone. 1/4, and now cosine squared of 2x is 1 plus cosine double that angle divided by 2. So if I double 2x, I get 4x. Okay, so now leave that alone, leave that alone. 1/4 times 1/2 is 1/8. And then I still have 1 plus cosine 4x. Okay, distribute, leave that alone, leave that alone. 1/8 times 1, 1/8 times cosine 4x. And the last thing is I can combine these two. So 1/4, which is 2/8. 2/8 plus 1/8 is 3/8. So final answer 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. So it's a big mess, but this is equivalent to the original sine to the fourth of x, and there's no more exponent. There's no squared or cubed or whatever. Okay. This is an important skill that you'll need when you get to calculus. Just a heads up, when you get to calculus, sometimes in calculus, you don't want to have any squared in your trig function. You just want to have stuff raised to the first power, and everything here is raised to the first power. So there it is. Okay. All right, then I was just going to do a couple more for you. Now, this way. We have some identities at the end. Okay, and let's see. Yeah, I noticed we have a some are different, so we should skip 27 and 29. And so skip 27, 29. Skip 27, 29. So we're not doing any somewhat different. Okay, identities. Remember doing identities in trig? The left-hand side, show that it's the same as the right-hand side. I'll show you a couple of those. Okay, so here's 37. Secant x minus cosine x equals sine x tan x. Okay. Your trig teacher may have taught you a different way. Here's the way I want you to do it. Okay. Right across the equal sign, draw yourself a vertical line here to separate these two. That's to tell me I can work on this side. I can work on this side independently. And then hopefully the goal is to get them to be equal to each other. What you're not allowed to do by the rules of the game is to, let's say, multiply both sides by the same thing. So multiply both sides by 2, not allowed. Square both sides, not allowed. Okay? So that's supposed to be a barrier. It's an impenetrable barrier, as to say, you work on this side independent of this side, and hopefully I get them to match. Okay, so I work on this side, I can work on this side, and hope I can get them to match. All right, one common trick is to change everything to sine and cosine. So secant is 1 over cosine minus cosine x over 1. And then I get a common denominator, multiply top and bottom by cosine x, cosine x. So that gives me 1 minus cosine squared x over cosine x. And then I do recall that 1 minus cosine squared is equal to sine squared. So sine squared x over cosine x. That's good to get. Can I do anything on this side? I'll change sine x, tan x to sine x over cosine x. And this indeed is sine squared x over cosine x. So there it is, they are equal. And so for proofs, draw yourself a line in the middle. You can work on the left side, you can work on the right side. The barrier is to indicate you can't do the same operation on both sides. You're not supposed to multiply by cosine x. You can't take the square root of both sides. Work on both independently, hopefully end up with them matching. Okay. I'll just say off to the side, some of you, your trig teacher may have said you're only allowed to work on one side. Okay. Why am I letting you work on both sides? Well, here's one side. Just take this statement, sneak it down here. Take this statement, sneak it down here. Take this statement, sneak it down there, and they're all on one side. Okay, so technically it is the equivalent, or the one side is, here's the first step, next step, slide over here, that's the next step, that's the next step, that's the next step. Okay, so your path is going like this, so to speak. Okay, all you have to do is just slide that down in here, slide that one down in here, slide that one down there, and there, it's all on the same side. Okay, so it is equivalent, what I'm giving you is equivalent to those trig teachers who insist only work on one side. There, just slide these over, it's on one side. Okay. Okay, then 4.743, it says find all values of x in the interval from 0 to 2 pi that satisfy the given equation. Okay. Tan x plus cotangent x equals 2 over sine 2x. Well, I'm practically going to work it out almost like an identity. Okay, tan x plus cotangent x equals 2 over sine 2x. Now, I have an identity that says sine of 2x is equal to 2 sine x cosine x. I can cancel these 2's. And on this side, I'll write it as sine x over cosine x plus cosine x over sine x. and then multiply both sides by sine x cosine x. So multiply both sides by sine x cosine x. This side is 1. Multiply this by this. Cosine cancels out, you have sine squared x. Multiply this by this, sine cancels out, you have cosine squared x. Sine squared x plus cosine squared x equals 1. That's always true. So this is actually an identity, but that doesn't mean everything works. I do have to go back and watch out for when these functions are undefined. Okay, and so I see the denominator has sine x, cosine x. That'll be undefined whenever sine x or cosine x is 0. And likewise, tan x looks like that. Cotangent x looks like that. Again, cosine x or sine x cannot be 0. So when it's either the sine or the cosine 0, that's here, 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 and here. Okay. So one way you can write that is the interval from 0 to 2 pi, which means I'm not counting 0, I'm not counting 2 pi, and then I throw out the set consisting of pi over 2, pi, and 3 pi over 2. Okay, so the interval from 0 to 2 pi, non-inclusive, throw these points out. Another way you can write it is go from here to here, 0 to pi over 2, union here to here, pi over 2 pi, union here to here, pi to 3 pi over 2, union here to here, 3 pi over 2, that's 3 pi over 2, 2 pi, where all these are open intervals. Okay. So here's kind of a clumsy way to write the whole thing. I think it's a little bit more compact to write it this way, but there we go. That's pretty much about it for that. All right, folks, that was all I was going to cover today. Okay, so I'm just about done with 4.7. I can start 4.8 coming tomorrow. Okay, so I'm done. Let me stop the share. Check the chat. If anybody wants to ask a question now, you may.
Could we go back to number 5? Could I see your work for that one more time?
Number 5, tangent of pi over 12. Okay. Let's see what I did with it. Okay, so write it as tangent of 3 pi over 12 minus 2 pi over 12. And since tangent sine over cosine, I wrote it like that. Then I use the formula for sine of a minus b, and the formula for cosine of a minus b. Reduce 3 pi over 12 to pi over 4, both of them. Reduce 2 pi over 12 to pi over 6, both of them. Then here's the formula for sine of a difference. Here's the cosine of a difference, cos, cos plus sine, sine. That, clean it up. That, clean it up. Then I take the ratio, that divided
No,
by
I
that.
see it. I see it now. I was checking my answer wrong on my calculator. I used the tangent identity of some difference, and I thought I did something wrong. But no, it's all adding up. Thank you.
Okay. All right. Anybody else? Let me check the chat. Nothing in the chat right now. Any other questions, please? Otherwise, we're going to call it a day. All right, that's it for today, folks. So everybody have a good day, and we'll see you next time. Okay. All right. Bye.
Thank you.
Thank you.